Was there any specific moment when you thought, oh my goodness, this is a possibility to use this technology to make a vaccine, all the way in the 1980s?
So there was two kind of events. The first one was the aha moment about using gene therapy technology to produce vaccines. And that happened because I was working very closely with a kind of a postdoc mentor whose name is Dan St. Louis. He still lives in San Diego. And Dan was working on a system where he would use retrovirus vectors to put genes expressing a secreted protein into cells of a mouse, and then collecting them in a little package, a nodule, we could say, placing them as a transplant into the mouse, and then the mouse would continue making the protein. Okay, so this was putting things into engineered cells in cell culture and then implanting them back in the mouse. That was the model, using a retrovirus. And Dan ran into a problem. It was a huge paradox in the laboratory. The cells would produce the protein in the mouse for about 3 weeks, and then they would stop producing it. And Inder's lab, where I was, Inder Verma, one of the top leaders at the time in regulation of gene expression, and the others who were supporting him in that mission, thought that this must be what was happening was some sort of a control event, that the retroviruses were getting turned off in the cells. And the aha moment for me, as somebody trained in medicine for a couple of years and immunology and vaccines and all that, was, good heavens, this is happening at 3 weeks, which is exactly the timeline for a good, robust cellular and humoral immune response. Probably what's going on is not some epigenetic, fancy chromosomal silencing thing, but rather simply that the mouse is making an immune response against the foreign protein. Mm-hmm. And lo and behold, that was what happened. Now, it seems like a very small thing in retrospect, but it was heresy at the time. Gene therapy had not yet come to confront the fact that it has this fundamental logic flaw, which is if you're putting the good gene into a patient, the patient's immune system doesn't know that it's the good gene. It only knows that it's a foreign gene. And it will mount an immune response against it, and it will also mount an immune response against the vector if it's an adenovirus or a retrovirus or whatever. Okay, so this aha moment seems trivial in retrospect. At the time, it was a kind of heresy and not well received, as you might imagine. But that was one of the key ones. Was gene therapy can be used. It may not ever. Remember, I come into this a true believer in gene therapy. This is going to be my career. Okay, I'm all in. Okay, and suddenly the epiphany. Oh, this isn't going to work so good. What are we going to do about it? Right? Because if you've got an immune response, there's no going back. Then you're into immune suppression land and really complex science, and that doesn't work very well. But the aha was, one of the way out of the woods is that we can use gene transfer technology to make vaccines. Mm-hmm. And so that was a key aha. And I thank Dan St. Louis for helping me and mentoring me at that time when I had that brainstorm. Wow. The other one that was kind of pivotal was way downstream and happened because of this serendipity that I was working with a non-viral method for transferring RNA into cells. And then because I was working as a teaching assistant in an embryology course at UC San Diego, and I had extra Xenopus embryos. So these are basically early stage tadpoles. Mm-hmm. And I took the material that I had been using for cell culture to test. I was testing a whole large array of cell culture lines for the ability to put RNA into them. And I said, well, let's just see what happens with these frog embryos. And those RNA experiments worked, to my great surprise, astonishment, really. They worked
Wow.
incredibly well. And then we, the next stage in the embryology course was some experiments involving chick embryos. And so I did this kind of same thing. Well, if it works with frogs, what about chicks? And lo and behold, I got signal with chicks. And so at that point, then things got serious and interesting. And disclosures were filed, and people started wrestling over who got ownership and all those kinds of things. And it all went sideways.